Hello. In this video, we will go over the final exam, practice exam, and this will be under derivative section. So this is Calculus 1 final exam, and this will be on the derivative section. So let's start with question 1. So question 1 says we have y equals x over x plus 1, and we got to find y double prime of 0. So how would we do this? Well, it says to specifically say second derivative because it has two apostrophes. So how would we take the derivative of the first one? Well, I noticed that it's a fraction. So you're gonna have to no cho you have no choice to use the quotient rule. So if you recall this is the quotient rule, I'll write it down. So f prime of g minus g prime of f over g squared. So what I'm going to do is figure out what is my f and what is my g. So my f is the numerator, which is f equals x, and then g is the denominator, which is x plus 1. Okay, so f prime is going to be positive 1, the g prime, the derivative of x plus 1, well, the derivative of x is 1, the derivative of 1 is 0, so it's just 1. So we have everything we need, so let's find y prime first, then we can find second. So y prime is f prime, which is 1, times it by regular g, which is x plus 1, minus, and then I'm going to put a little bracket because I will have to distribute this minus. G prime is positive 1, and then f is x. And then it's all over g squared. So g is x plus 1, and we got to square that. So what I would do next is clean it up a bit. So 1 times x plus 1 is just itself. 1 times x is x, and then I'm going to distribute this minus, so it's going to be negative x over parentheses x plus 1 squared. Okay, so y prime is going to be x and negative x cancel, so you're just left with 1 over x plus 1 squared. Now, we got to find the second derivative, so we got to find y double prime. Now, I'm going to do something different. I'm not going to, you see this pro I'm not going to use the quotient rule. I have a 1 on the top and an x plus 1 square on the bottom. You'll probably think, well, this has to be in a fraction. I have to use the quotient rule. Not quite. You can actually rewrite this as a negative power. So how would I rewrite 1 over x plus 1 squared as a negative power? That is the same thing as x plus 1 to the negative 2. Okay, so from this, what can we use? We can use the power rule and the quotient rule. I mean, a power rule and the chain rule, right? So from here on, we no longer have to use the quotient rule because it's no longer a fraction, but we'll have to use the power rule and then the chain rule because there's something inside the parentheses, right? So let's do that. So start with the power rule. So this has an invisible 1. So what's 1 times negative 2? Negative 2. Leave the outer parentheses alone. And then it's going to be all power minus 1. So negative 2 minus 1 is negative 3. Okay, so we did the power rule. Now do the chain rule. So basically, it's just the derivative of the inner parentheses. So what is the derivative of x plus 1? Just 1. So let's kind of clean this up. 1 times negative 2 is negative 2. And then we have x plus 1 to the negative 3. So we have y double prime. Hmm. That's not our answer because it specifically said find y double prime of 0. So let me clean this up a bit. Let's rewrite this as only positive power. So this is negative 2 times 1 over x plus 1 to the third power. So this is the same thing as negative 2 over x plus 1 to the third. So what is y double prime of 0? All you gotta do is replace x with 0, so it's gonna be negative 2, 0 plus 1 to the third. So that's negative 2, and then 0 plus 1 is 1 to the third. So that is going to be negative 1, negative 2. Okay, so that's y double prime of 0, which is negative 2. Okay, so let's move on to question 2. So we have f of x equals sine square of x, and we got to find f double prime. So which technique shall we use? First off, I can rewrite this problem. Sine square of x is the same thing as sine of x all raised to the second power, right? So how do we take the derivative of this? It looks like we can use just for this part, or just find f prime, we would have to use power rule and chain rule. Okay, so let's start with the power rule. So this has an invisible 1, so what's 1 times 2? 2. Leave this inner parentheses alone, so leave sine of x alone. And then continuing with the power, what's old? It's old power minus 1, so 2 minus 1 is 1. And then apply the chain rule. So what is basically the derivative of the inner parentheses? So what's the derivative of sine of x? Yes, it is cosine of x. So when we put it all together, what is 2 times sine of x times cosine of x is it's just itself, right? Um, okay, so we found f prime, but that's not our answer because we want f double prime, right? So how would we take the derivative of this? Well, 2 is a constant, and then it's multiplying two things, sine of x and cosine of x. So when you're multiplying two things, you're most likely going to use the product rule, right? So if you recall, this is the product rule, f prime of g plus g prime of f. So you could factor out the 2, or you can say that f is 2 sine of x and g is cosine of x, right? So f prime, what is the derivative of what is the derivative of 2 sine of x? It'll be 2 cosine of x. What is the derivative of cosine of x? It is negative sine of x. Okay, so we have everything we need. So we'll just say f double prime of x is product rule. So f prime is 2 cosine of x times it by regular g, which is cosine of x, plus g prime, which is negative sine of x, times f, which is 2 sine of x. Okay, so f double prime of x. So what's 2 cosine of x times cosine of x? That is 2 cosine square of x. What is negative sine of x times 2 sine of x? That is negative 2 sine square of x. Is there anything you could do with this one? I mean, can we do any kind of simplification? Yes, we can. We can maybe factor out 2, so this would be 2 cosine square of x minus sine squared of x, right? Any identity we could use? Yes. Did you know that cosine square x minus sine square of x is an identity? It's a double angle identity. So this right here is a double angle identity. So yeah, this simplifies as cosine of 2x. So did you know that cosine of 2x is the same thing as cosine square of x minus sine square of x? Okay, so now you know. So this is going to be 2, and then just replace that with cosine of 2x. So your final answer, you'd say f double prime of x is 2 cosine of 2x. Do not multiply the 2 and the 2, so just leave it as it is. And that's your final answer. So it's pretty cool. If you know your identities and your identities, it comes out really nice. The other option is yeah, that's it. I was thinking, is there another way you can express this? Not that I know of. Okay, so this is our final answer. Let's move on to question 3. We have g of x equals x fourth over 32 minus 5x squared, and we must find g prime of fourth. Okay, so if you want, this isn't a bad one, but the thing is x4 over 32, it looks like it's a fraction, and you might want to, you might have to, and you're probably thinking, we'll have to use the quotient rule, right? Not quite. Did you know you can rewrite this problem? X to the fourth over 32 is the same thing as 1 over 32 x to the fourth. So you could put, if the x, you could put the x on the top or on the center, okay? Now let's go ahead and find g prime of x. So now for these ones, you could just use the power rule for each term. So for this whole thing, you can use power rule and then this whole negative 5x to the power. So over here, power rule, so 4 times 132 is 4 over 32. And then x, and then old power minus 1. 4 minus 1 is 3. And then the derivative of negative 5x squared, that's power rule. So 2 times negative 5 is negative 10. X to the power of 1. And let's see, what else could we do? I think we could reduce the 4 over 32, correct? That can be reduced by 4, so that would be 1 over 8 x cubed minus 10x. And then lastly, just plug in, because they want g prime of 4, so go ahead and plug in where we see an x, plug in 4. It's going to be 1, 8, and then replace x with 4, so that's 4 to the third minus 10 to the fourth. So when you do all the algebra and you just put in the calculator, you are going to get negative 32. Okay, so that was question 3. So move on to question 4. Question 4 says equation of the line tangent to the equation. So they want to know the equation of the line that is tangent to f of x equals 4x cubed minus 7x squared at the x coordinate, at the x value 3. So when they want you to find the equation of the line that's tangent, whenever they ask you for the equation of the line tangent, you're gonna need the point slope form. So first you're gonna need to need a point. You're gonna need a point I mean, a coordinate, when I say point, coordinate, and then you're gonna need to, you need to find the slope. Why? Because you're gonna put, your final answer will be in this form. Okay, so do we have a point? Not quite. We have an x value 3, right? So they don't tell us the y coordinate. So sometimes they'll be really tricky and they'll just give you an x coordinate and they won't give you a y. So that's the first thing I always check. If you actually have a coordinate, we don't. So how do you find the y coordinate? All you got to do is plug in 3 into f of x. That's it. So go ahead and do that real quick. And when you put it all together, it spits out 45. So now you have a point. So your point is at 3 comma 45. Now, do we have the slope? No. How do you find the slope? You take the derivative and then all you got to do is plug in, because we don't, for the f of x, we don't have a y, so all you got to do is plug in your x value 3. So let's do step 2. We're gonna find a point. I mean step 2, find the slope. Because we already have the point, right? So how do you find the slope? You take the first derivative. So this one's not too bad. You just use power rule. So what is the derivative for x cubed? It's going to be 12x squared because I just used power rule. And what is the derivative of negative 7x squared? It would be negative 14x to the 1. And then plug in your x value 3. So that's 12 times 3 squared minus 14 times 3. And it spits out 66. So what that means, that 66, that represents your slope or your m. And then once you do that, just put it in point slope form and you are done. So it's going to be y minus y1. So y1 and x1 represent your point coordinate. So my point is 3 comma 45. So my y1 is going to be 45. And then my m is going to be 66. And then it's going to be x minus x1, which is 3. And I believe that's it. That's your final answer. Okay. Well, that was question 4. Let's move on to question 5. So question 5 says we have f of x equals x squared cosine of 2x, and we got to find f prime of x, right? So how do we take the derivative of this whole thing? Since there's two things that are multiplying, this is one term, and cosine of 2 is actually one term. You'll have to use a product rule. So here's a product rule. Okay, so what's your f and your g? So your f is x squared. Your g is cosine of 2x, right? Okay, so f prime is going to be 2x, and then g prime. How do you take the derivative of cosine 2x? You use chain rule. So what's the derivative of cosine? It is a negative sign, and then leave 2x alone. And then you apply the chain rule. So what's the derivative of 2x? Just positive 2. So you can clean this up a bit. What's 2 times negative 1? Negative 2 sine of 2x. Okay, and then you just apply the product rule. So f prime of x is f prime, which is 2x. Regular g is cosine 2x plus g prime, which is negative 2 sin of 2x times by half, which is x squared. And then put it all together, clean the things up. Your final answer shall be 2x cosine of 2x minus 2x squared sin 2x. And then you find answer. Okay, so that's 5, question 5. Let's move on to question 6. Uh, okay, so 6, we gotta find dy dx. This is like implicit differentiation. If y equals arc sin of square root of x. So whenever you see the word arc, that's the same thing inverse. So you can rewrite this as y equals sin inverse of square root of x. And square root of x is the same thing as x to the 1/2. So I'm gonna do that. You'll see why. So now we've got to find dy dx. So what is dy dx? It's basically saying take the derivative of this in respect to x on both sides. So look on the left side. What is the derivative of y in respect to x? So it's usually when you're doing implicit differentiation, it's usually in respect to x or in respect to time. So here's a little trick how I do this. So how do yes, what is the derivative of y? Because we're taking when we're doing implicit differentiation, we do it we do it on both sides. So what is the derivative of y or 1y in respect to x? So what do you put on the top and what do you put on the bottom? Well, I know the derivative of y is just regular 1, right? Because of power rule. And then you're going to have to put your letters. So on the top, it's going to be a dy. And why why do I put a dy? It's because on the top it's always a letter what you have. So in our case we started with y, so that's why I put dy. And then on the bottom, you're going to put whatever you're taking the derivative in respect of. So we're taking the derivative in respect to x. So we're going to put a dx. Okay. You could disregard this one if you want. You can also just say dy dx. What about the right side? What is the derivative of sin inverse of x to the 1/2 in respect to x? So let's just take the derivative of sin inverse of x to the 1/2, right? Without figuring out the letter. Well, what would that be? Uh, it is going to be, it's like one of the special ones. It is going to be 1/2 x to the negative 1/2 over the square root of 1 minus your a value. So this is your a value. So that's going to be x to the 1/2 squared. And let's clean this up. So we have over here, this is your numerator. What's x to the negative 1/2? That is the same thing as 1 over 2 to the x to the 1/2. And if you clean that up, that's also the same thing as 1 over 2 x to the 1/2 is the same thing as square root of x. And then on the bottom, uh, this whole thing right here is your denominator. So what is that going to be? It's going to be square root of 1 minus what's x to the 1/2 squared? Well, remember when you raise, you multiply the exponent. So 1/2 times 2, it disappears. You're just left with x. Okay. So we have a complex fraction. When you do that, when you clean this up, you're going to get this. 1 over 2 square root of x times 1 over square root of 1 minus x. Okay, so if you do the algebra, right, this is a complex fraction, so you can re so this whole thing is your numerator, this whole thing is your denominator, so you can rewrite this as 1 over 2 squared of x divided by uh square root of 1 minus x over 1, right? And then you would cross multiply. This is what you would get. Now, you're probably thinking, why don't I add a dy dx? Well, this is why we don't. So our letter was x's, right? So on the top, it's what the letter you have. So ours was we started with x. So you put a dx on the top, and then on the bottom, it's whatever you're taking the derivative in respect of. So we're taking it in respect to x, so you're going to put a dx in the bottom. What happens is this cancels, so you're just left with nothing. Okay, so that's your final answer. Okay, so let's move on to question 7. Question 7 says find the instantaneous rate of change of W with respect to Z if W equals Z over 3Z squared. So find the instantaneous rate of change. So that's basically saying find dy over dz. That's what they're saying. Find the instantaneous rate of change of W with respect to Z. So that's why I put a Z on the dz on the bottom because it's what we're taking it in respect to Z, and then dw is what we have, right? And this is what we have. We have, so this, our goal is to find dw over dz. But what we have is this, w over 7 3z squared. So what can I do? Um, over here, so if we're doing implicit differentiation, what's the derivative of w in respect to z? That is going to be dw over dz, right? You put on the numerator, it's the letter what you have, and then on the bottom it's what you're taking it in respect of. So we're taking it in respect to z, so that's why I put a dz in the bottom. Now over here, 7 over 3z squared. I'm going to write that as a negative power. I think that's more easier. So this right here is the same thing as 7/3 z to the negative 2, right? That's much easier because now you can just apply the power rule, right? So negative 2 times 7, that's, I mean, negative 2 times 7/3, so that's 7/3 times negative 2. And then z, and then continuing with the power rule, it's old power minus 1, so old power is negative 2, minus 1, which is negative 3. Okay, so you get dw over dz. So what's 7/3 times negative 2? That's negative 14 over 3. And then z to the negative 3, if you want to write that as a positive power, it's 1 over z30. So you can put the z3 on the bottom. And that's your final answer. Okay, so let's move on to question 8. Differentiate y equals 1 plus cosine x over 1 minus cosine x. And what technique shall we use? It's not implicit differentiation, so uh, it says differentiate. I differentiate, so you can do y prime, or you can also say a dy dx. Maybe I'll just stick with dy dx because we are technically we just did implicit differentiation. It's the same thing as y prime, so it's up to you. So I see that's in a fraction, so we're probably going to have to use the quotient rule. So it's going to be f prime of g minus g prime of f all over g squared, right? So first, figure out your f and your g. So your f is the numerator. So your f is 1 plus cosine of x. And your g is at the bottom, 1 minus cosine of x. Okay, so f prime. The derivative of 1 is 0. The derivative of cosine of x is negative sine of x. G prime. The derivative of 1 is 0. The derivative of negative cosine is positive. The derivative of negative cosine of x is positive sine of x. Okay. So you could say dy dx, or you can also say y prime. And then just apply the quotient rule. So f prime of g, f prime of g minus g, f prime of g minus g prime of f over g squared. So my f prime is negative sine of x. And my regular g is 1 minus cosine of x minus bracket. G prime is sine of x. And then f is 1 plus cosine of x. All of the squared. So it's going to be 1 minus cosine of x squared. And this up, uh, what you're going to get. So when you FOIL this out, you're going to get negative sine of x plus sine of x cosine of x minus bracket. When you do all the algebra, this is what you're going to get. Your final answer should be negative 2 sine of x over 1 minus cosine of x squared. So this is your final answer. Let's move on to question 9. So dy dx, we got to find dy dx. So basically, the derivative of this, right? So we could say dy dx is equal to. So how do I take the derivative of ln of parentheses x fourth plus 8? So you ever see an ln? So the derivative of ln of x is 1 over x times the derivative of the parentheses. So it's 1 over x. So it's the same concept. The only difference is our parentheses is not x, it's x fourth plus 8. So it's going to be 1 over this whole thing times the derivative of x fourth plus 8. So what's the derivative of x fourth? It is 4x cubed, and then the derivative of 8 is 0. So your final answer is going to be dy dx. It's going to be, that's going to be 4x cubed over x fourth plus 8. Okay, that wasn't too bad. Okay, number 10 says, at how many different values of x does the curve y equals x cubed plus 2x have a tangent parallel to the line y equals x? So what we have to do is find y prime. So we have two equations, right? We have y equals x cubed plus 2x, and then the other one is y equals x. So how do you know if two lines are parallel? Their slope. So how do you know if two lines are parallel? Right? Here's line one, line two. The slope must be the same, right? M1 must equal to M2. So let's take the derivative of each of both equations. So y prime. So what is the derivative of x cubed plus this is a 2x. What's the derivative of x cubed plus 2x? It is going to be 3x squared, and then the derivative of 2x is 2. And then what about here? What's the derivative of y equals x? It is going to be 1. So what you're going to do is once we find the derivative, we're going to set each equation to each other. So we're going to say 3x squared plus 2 equals to 1. Okay, so go ahead and continue solving for x. So what I would do is subtract 2 from both sides. So you get 3x squared. And then 1 minus 2 is -1. Divide this by 3. You get x squared equals to -1/3. Take the square root of both sides. Now we kind of have a problem. You cannot take the square root of a negative, so you're dealing with imaginary. So there will be no real values, so no values of x. Okay, let's continue to question 11. So question 11 says, a particle moves along a straight line with the equation st equals t squared minus 2t. Find the instantaneous velocity of particle when time is 0. So what they're really trying to ask is, when they say find the instantaneous velocity, they're basically saying find v of 0. That's what we're trying to find. So they give us st. I think that's our position. So to find vt, you gotta find it's the first derivative, right? So we gotta find s prime of t, and then let's do that. So what is s prime of t? So what's the derivative of t squared minus 2t? The derivative of t squared is 2t. The derivative of -2t is -2. Then what we'll do is, because we want to find v of 0, we'll replace times 0, so that's going to be 2 times 0 minus 2, which is -2. So find the instant velocity, it would be -2. Okay, number 12 says we have f of x equals secant of x plus cosecant of x. We got to find f prime of x. So how shall we do this? I would just take the derivative of each term because they're not adjacent, they're not squished, so we can't use particle. It's not in a fraction, so we don't have to use quotient rule. So just take the derivative of each term. So what is the derivative of secant of x? That is going to be a special one. That's going to be secant of x times tan of x. And what is the derivative of cosecant of x? That is going to be negative c as cx times cotan of x. So your final answer will be basically this. So it's be secant of x tan of x minus c as c of x times cotan of x. Okay, so that is my final answer. Okay, so let's move on to 13. So 13 says find d squared of y over dx squared for y equals 4 cosine square of 4x. So basically implicit differentiation twice or y double prime. So what I would do first is find dy dx. So this is what we have. So can we rewrite this problem y equals cosine squared? Can we rewrite y equals cosine square of x of 4x? Yes, we can. This 2 is right next to the s, cosine, so that's the same thing as cosine of 4x all raised to the second power, right? So let's first find dy dx. So it's going to be dy dx because the derivative of y in respect to x is dy dx. Now let's do the right side. So what is this? What's the derivative of this whole thing in respect to x? Well, how do you do this? We're going to have to use power rule and chain rule. So start with the power rule. So 2 times 1 is 2. Leave the inner parentheses alone. And then old power minus 1. So 2 minus 1 is 1. And then use the chain rule. So what is the derivative of cosine of 4x? It is the derivative of cosine of 4x is negative sine of 4x times, it's like taking using the chain rule twice. The derivative of 4x is 4. And when you clean this up, you're going to get negative 4 to sine of 4x cosine of 4x. Now, is there any, this looks like a mess, but is there any identity you can use? Yeah, 2 sine of 4x cosine of 4x. That's a special one. That's a double angle. So this is going to be, yeah, did you know that sine of 2x is the same thing as 2 sine of x cosine of x? And then did you also know that 2 sine 5x times cosine of 5x is the same thing as sine of 10x? So 2 sine of 4x times cosine of 4x is the same thing as sin of 8x, right? Because of the double angle identity. 2 sin of 4x times cosine of 4x is the same thing as sin of 8x. And then you still have this negative 4. Okay, so dy dx is this, but that is not our answer. We gotta take the second derivative. So you're probably gonna need this. That's why we need this. So d squared of y over dx squared So now, what is the derivative of this? This is not too bad. So -4 is a constant, so just take it out. And then what's the derivative sine of sin of 8x? You use chain rule, right? So first off, the derivative sin is cosine of 8x, and then what is the derivative of 8 of x? What is the derivative of 8x? It's 8. So when you put that all together, you can multiply 8 and -4, which becomes -32 of cosine of 8x. Okay, so that is that. So my final answer is going to be -32 cosine of 8x. Okay, let's go from 1 to 14. So 14, we have f of x equals cosine cube of x plus 1, and we got to find f prime of 4. So see, what I'm going to do is rewrite this as cosine cube of x plus 1 is the same thing as cosine of x plus 1, all raised to the third power, right? So how do you take the derivative of this? You just use power rule and chain rule. So start with the power rule. So 3 times this has a 1, so 3 times 1 is 3. Then it's going to be cosine of x plus 1 square. And then this is like, so this is like your u. So you got to take the derivative of this whole thing. So what is the derivative of x plus 1? Cosine of x plus 1. It's like trig and chain rule, right? So the derivative of cosine is sin. And then you take the derivative of x plus 1, which is 1. So when you put it all together, you get sin of x plus 1. And, oops, sorry. The derivative of cosine is actually negative, so there should be a minus. So it's going to be -3 cosine of x plus 1 squared times sin of x plus 1, right? So this is f prime of x. So f prime pi, so wherever you see an x, plug in pi. -3 cosine of pi plus 1 squared sin of pi plus 1. And that's it. You can just leave it like this. Okay. Let's move on to 15. So 15 says the slope of the curve of y cubed minus xy squared equals 4 at the point of y equals 2 is. So what are we there? So they're asking for the slope of the curve when given this at the y value 2. So they're not asking for the equation, they just want to find m, right? Or dy dx in our case. So our goal is to find dy dx. Um, what do we need? First, what we need is an actual point. do we have a point or a coordinate? Not exactly. They tell us that y equals 2, but we don't know what x is, right? So that's the first thing I'm going to find. I'm gonna use this and I'm gonna replace y with 2. So it's gonna be 2 cubed minus x, and then y is 2. Square equals 4. So 2 cubed is 2, 4, 8. And then 2 squared is 4. And then you have a negative x, so that's negative 4x equals to 4. And then continue solving for x. So subtract 8, and you get negative 4x. And 4 minus 8 is negative 4. Solve for x by dividing both sides by negative 4. And you get x equals 1. Okay, so we found the point. So our point is at 1, comma 2. Now let's find the slope. So basically, go back to here, take the, uh, yeah, go back to that, and then just find dy dx. So what is the derivative of y cubed in respect to x? Well, the derivative of y cubed in general is 3y squared. And then because we're doing implicit differentiation, it's going to be you're going to add a dy dx. So why did I put a dy on the top? Because that was the letter that was given. Why did we put a dx on the bottom? Because we're trying to take it in respect to x. What about this middle term? How do we take the derivative of that? And unfortunately, we'll have to use the product rule because they're squished. Your so if you use the product rule, your f is like negative x and your g is y squared, right? So f prime is negative 1, and then g prime, oops, is 2y dy dx, right? Why didn't I put anything for the x's? Because remember, it's for the x's, it's going to be a dx of a dx, which really becomes 1. Okay, so when you apply the product rule just for this, we're going to get minus. So you can actually, I put a minus here. You could have just factor it out and then do that. So if you did factor it out, you're going to get f prime of g plus g prime of x. So it's going to be 1 is 2 times 2 times dy dx plus 2 square times 1. And then on the other side, so this whole thing right here, and when you apply the product rule, this is what you're going to get. And then the derivative for it is 0. So kind of clean this up. So you're going to get 12 dy dx minus 4 dy dx plus 4 equals 0. You get 12 dy dx minus 4 dy dx minus 4 equals 0. And then go ahead and solve for dy dx. So uh, so first I would add 4, get 12 dy dx minus 4 dy dx equals to 4. And then what you could do is like factor out see how they both have a dy dx, you can factor out a dy dx, you can also factor out a 4. So actually you can combine them. What's 12 dy dx minus 4 dy dx? It's 8 dy dx equals 4, and then get rid of the 8 by dividing 8 or multiplying both sides by 1/8. And you get dy dx equals 1/2. Okay, let's move on to 16. So this one is also an implicit differentiation. We must find dy dx when we're given sin of xy, sin of parentheses xy equals x. So when implicit differentiation, you always got to do the left side and the right side. So let's start with the left. So how do we take the derivative of sin of xy in respect to x? Just take it, don't worry about the just take it and just do it. What's the derivative sin? It is cosine of xy, and then you got to use the chain rule. So this is the part where it can be difficult. So you're taking the derivative of xy, and you got to use the product rule. So your f is x, and your g is y. And be careful, we're taking it in respect to x. So the derivative of x, or 1x, is 1, and then in respect to x, you can put dx over dx, but that still becomes 1. And then g prime, the derivative of g prime is 1 dy dx. Okay. So when you put it all together, so the product rule is f and then g equals g prime of f. So, so you're gonna get cosine of xy times product rules f prime is 1 times it by g, which is y, plus g prime, which is dy dx, times it by f, which is x, equals to, so we did the left side, now what's the derivative of x? Uh, did I do that right? Yes. And then what's the derivative of x in respect to x? 1, right? So what do we have to do is we got to find dy dx. Um, what could I do next? I could get rid of this cosine of xy. So that's what I'm going to do by dividing both sides by cosine of xy. So now you have y plus, and then I'm going to put this x in front. So it's going to be y plus x dy dx equals to 1 over the cosine of xy, right? And then continue solving for dy dx. So what I would do next is subtract y. So you get x dy dx of 1 over cosine of xy minus y. And then lastly, get rid of this x by dividing everything by x. So when you put it all together, so this cancels. This is a complex fraction, and somehow that becomes a secant xy. So when you put it all together, you get dy dx equals the secant of xy minus y all over x. Is your final answer. Next one, 17. Okay, so 17 says tangent to the curve of y equals x e raised to the negative x is horizontal when x equals 0. So how do you know something is horizontal? So let's say you had a curve and something that's horizontal, a tangent that's horizontal is basically like this. And what do we know about slopes of a horizontal line? It's always going to equal to 0. So what they're really trying is, what they're trying to say is find dy dx, find the slope when it's 0. So what we're going to do is find dy dx, then set that equal to 0, and then you solve for x, right? So this is what we have. So the derivative of 1y in respect to x is dy dx. The derivative x e to the negative x is unfortunately the product rule. So your f is x, your g is e to the negative x, your f prime is 1, your g prime is what's the derivative of e to the negative x is like e to the negative x, and then the derivative of negative x is -1. So then you apply the particle, which is f prime of g plus g prime of f. So f prime is x e to the negative x of -1 plus e to the negative x times 1. So you get dy dx is when you clean this up, you're going to get negative x e to the negative x plus e to the negative x. Okay, so we found dy dx. Then what we got to do is set this to 0 and somehow solve for x. So over here, I noticed that they both have an e to the negative x, so you can factor that out. And you get negative x plus 1 equals 0. And then what you could do next is set each equation to 0. You could say e to the negative x equals 0, and then you can also say negative, or you could say negative x plus 1 equals 0, right? So over here, e to the negative x will not work because e to the negative x is the same thing as 1 over e to the x equals to 0 is over 1, and then when you cross multiply, it will not work. Over here, it might work, so I will subtract 1, and you get negative x equals -1, and then divide this by -1, and you get x equals to 1. Okay, so that's 17. Let's move on to 18. So number 18, we have cosine of x equals e to the y from 0 to pi, find dy dx. So just take the derivative of both sides. So what's the derivative of cosine of x? It is negative sine of x. What's the derivative of e to the y in respect to x? Be careful. So the derivative of e to the y is e to the y. But in respect to x, you do have to add that dy dx. Okay, and then go ahead and solve for dy dx. So you're going to divide both sides by e to the y, e to the y, and you get t1 tx is negative sine of x over e to the y. And is there anything else we could do? Post. Yes, you can. Be careful. Did you know that they're saying that e to the y is the same thing as cosine of x? So you can replace this e to the y with cosine of x. I almost forgot about that. And what is negative sine of x over cosine of x? It is negative tan of x. So dy dx equals negative tan of x. Okay, let's move on to 19. Okay, so 19 says f and g are differentiable. We have f of 1 equals 2, f prime of 1 equals 3, f prime of 2 equals negative 4, and g of 1 equals to 2, and g prime of 1 equals to negative 3, and then g prime of 2 equals 5. If h of x equals f of g of x, find h prime of 1. So what to do? So what first we've got to do is find h of x. I mean h prime of x. So how do we find h prime of x? Well, they give us h of x as f of g of x. So how do you take it? You got to take the derivative of this, which is basically chain rule. So it's basically saying f prime of g of x times g prime of x, right? It's just chain rule. And then we got to find h prime of 1. So that's going to be f prime of g of 1 times g prime of 1. Now, this is where they give us all these information. So g of 1 that was given, that's going to be 2. So it's going to be f prime of 2 times g prime of 1. That's given. That was also negative 3. And then fill in more. They also tell us that f prime of 2 is also negative 4. Times it by negative 3. So h prime of 1 is negative 4 times negative 3, which is 12. Okay. Three more. I think the rest are word problems. So let's do 20. So the top of a ladder, the top of a 25-foot ladder is sliding down a vertical wall at a constant rate of 3 feet per second. When the top of the ladder is 7 feet from the ground, what is the rate of change of the distance between the bottom of the ladder and the wall? So let's kind of draw an image. So here you have a wall, right? And then here you have a ladder. And the ladder is 25 feet. That was given. So imagine this ladder is sliding down a wall, and we somehow got to find the rate, the speed, or the rate. What is the rate of the change of the distance between the bottom of the ladder and the wall? So imagine this ladder going down vertically, and basically we're trying to find dx over dt. And they give us a few things. What did they tell us? The ladder's 25 feet, yes. And what else do they say? They say that the it's sliding down at a vertical wall at a constant rate of 3 feet per second. So on this is your vertical, this is your horizontal, right? So they're basically saying dy dt, right? It's a speed at -3. That was given. So our goal is to find dx dt. So how do we do this? And what else do they tell us? That they say that when the top of the ladder is 7 feet from the ground. So I think that 7 feet represents this vertical distance, so that's 7 feet. So we still got to find dx dt because they're asking you what is the rate or what is the rate of change of the what is the rate of change of the distance between the bottom of the ladder and to the wall. So yeah, we gotta find dx dt. So we have a right triangle. So what I would do is first find out what this horizontal distance is. I could figure that out because I know it's a right triangle, so we can use Pythagorean theorem. So it'd be like 7 squared plus x squared equals 25 squared, right? So 7 squared is 49, x squared is x squared, and then 25 squared is uh 625. And then go ahead and solve for x. So add both sides, and you get x squared equals 625 minus 49 is 576. Square root, get. Okay, so this horizontal distance is 24. Okay, then we also have another equation. We can also say x squared plus y squared equals r squared. So this horizontal distance and this vertical distance equals the radius, r squared. So what we could do is, you'll see why we needed this 24 first. You'll see why I found this 24 first, because when you do implicit differentiation, what is the derivative of x squared in respect to time, not, yeah, time. So the derivative of x squared is 2x, and then in respect to time, it would be dx or dt. And then the derivative of y squared is 2y, and it's going to be dy dt. And then the radius is a constant of 25 squared. So our goal is to find dx dt, and they also give us, we can fill in one more thing. Um, oh, what's the derivative of 25 squared? It's a constant, so that's going to be 0, right? And then we can just fill in what we have. So our goal is to find dx dt, dx dt. So uh, over here, what's 2 times x times dx dt? Well, I know that my x We just found that that's 24. Do I know my speed dx dt? No, I don't. And then times 2 times y, 2 times y times dy dt. So do we know my y? Yes, that was given. That was 7. Do I know my dy dt? Yes, we actually know that. That was actually given. That's -3 equals to 0. So our goal is to find dx dt. So clean this up. 2 times 24 is 48. And then we have dx over dt. And then 2 times 7 times -3 is -42 equals to 0. And then go ahead and solve for dx dt. So add 42, you get 48 dx over dt, 42, and then divide this by 48. And then you get dx over dt. Yeah, you get dx over dt, just 7/8. Because 42 over 48 can be like reduced by what? 6. So that's how you got 7/8. Let's stop here. Yeah, let's stop here. Because the other twos are word problems and they take a bit of time, so let's just stop here.